Python is becoming the most important skill for modern biologists. Whether you work in molecular biology, genetics, microbiology, bioinformatics, or biotechnology, Python can automate your work, analyze huge datasets, and help you get better jobs. But most biology students feel Python is hard. So in this video, I'll take you from complete beginner to data analysis, step by step, using simple examples that all biologists can understand. Let's begin. Section 1. Why biologists should learn Python. Biology today is data-driven. We analyze genomes, FASTQ files, protein sequences, drug response data, qPCR results, and Python can do all of this faster and more accurately than manual work. Here's why Python is perfect for biologists. Easy to learn, SUDI-free and open-source UI. Used in genomics, NGS, AI bio, drug discovery, SUDI. Works with large datasets, free-acquired for high-paying roles. In fact, most global bioinformatics and biotech companies expect basic Python skills in 2026. Section 2. What you need to know, beginner level. 1. Variables store numbers, DNA sequences, etc. Example DNA equals ATGT DAC2. Lists and strings useful for handling sequence data. 3 loops to scan through DNA or protein sequences. 4 functions to organize your code and analysis steps. This is enough to get started. Section 3. Python tools for biologists. 1. BioPython for sequence analysis. FASTQ reading. BLAST automation FUDI 2. Pandas for tables, CSV files, qPCR data, gene expression matrices. 3. NumPy for mathematical operations in analysis. 4. Matplotlib Seaborn for plotting and data visualization. ID 5. SciPy Scikit Learn Ladder for statistics or machine learning. Section 4. Your first biology example, very simple. Example 1. Count GC content DNA equals ATGCG, TTA GCGT equals DNA count G plus DNA count. GCG % equals GCI len DNA. Asterisk 100 print GC content. GC %. This simple script shows why Python is powerful. You can analyze sequences in seconds. Example 2. Reading a FASTA file from bioimport Sequio for record in Sequio. Parsi sequence FASTA, print word. Print len record, seq. This alone helps with fundamental genomics tasks. Section 5. Data analysis for biologists. Beginner SUDI, intermediate. Python can analyze qPCR results, gene expression, matrices drug dose, response curves, protein abundance data, NGS count tables, CSV-XL-based lab results. Here's a simple pandas example. Import pandas as PD data equals PD read CSV gene expression. CSV print data head mean expression equals data expression. Mean print average expression. Mean expression. This is how bioinformatics pipelines begin. Section 6. Visualizing biological data. Gene expression plot. Import matplotlib. PyPlot as PLT, plot data. Gene, data expressions, BLTX label gene, BLTLT. We label expression levels, PLT title, gene expression plot PLT. Visualization is important for publication graphs presentation, slides research analysis, diagnostic data interpretation. Section 7. Real-world projects for beginners. Project 1. DNA sequence, Analyzer GC content, reverse complement translation project. 2. FASTQ quality checker. Use BioPython to read FASTQ files. Project 3. Gene expression dashboard, using pandas plus matplotlib. Project 4. Automate blast search, using BioPython's NCBI API. Project 5. COVID genome mutations finder. Compare sequences, 10 define differences. This portfolio makes you job ready. Section 8. How Python helps your career. Python opens doors to many roles. Bioinformatics analyst genomics. Technician data scientist. Biology drug discovery, analyst computational biologist, NGS data processor, machine learning in healthcare. Section 9. Where to learn Python, free and paid. Free, Kaggle YouTube, Google Colab tutorials, BioPython docs paid. Coursera Python, for everybody DataCamp bioinformatics courses. Udemy Python for biologists. By starting small with simple biology projects, you will watch your coding confidence grow exponentially with every successful script you complete. If you would specifically like a deeper, full-length video focused entirely on creating more Python projects for bioinformatics beginners, please comment a resounding yes below. I will absolutely make that specialized project guide next if there is enough interest from the community asking for it. Finally, please remember to smash that like button, share this guide with any fellow students, and subscribe to Labmonk Official for your weekly dose of bioscience career guidance.